Welcome to CIVIL-MECH-MATHS-CONCEPTS channel, wherein we have released about 65 videos on various topics for GATE and SSC JE examinations. GATE Engineering Mathematics, about 20 lectures have been released, and structural analysis, more than 20 lectures are released, and also in fluid mechanics, around 17 lectures are released. This is the 18th lecture. More than 60 lectures are released from this channel. Please view them, review them, and get the concepts so that you can understand the fluid mechanics 18th lecture today. In structural analysis, after discussing about the types of forces and also the beams, bending stresses, combined bending and torsion stresses, and shear stresses, bending moment, shear force diagrams and deflections, I again switched over to fluid mechanics, in which 17 videos are already released, in which I have discussed about the fluid properties, fluid mechanics, and calculation of the pressure, equipment used for the pressure measurement, and also pressure calculations, types of pressures, types of flows, and types of velocities, and various parameters, surface tension, capillarity. All these things are discussed in the previous classes. And hydrostatics and calculation of hydrostatic pressure is also discussed in the previous classes. Now in this class, we will be discussing or continuing our discussion on center of pressure. I had already discussed about the center of pressure. Let us continue the discussion. Let us go ahead. What is center of pressure? There is called center of gravity. That is CG. And another is center of pressure. Center of pressure is denoted by H bar, and moment of inertia. These terms I have already discussed. This can be H bar or HC, or somewhere it is called as YCP also. Moment of inertia, that is I, that is second moment of area. This second moment of area can be IXX, it is with respect to x-axis. ICG is with respect to center of gravity. We are interested in finding with respect to center of gravity. And to find ICG, we use parallel axis theorem. This is used for calculating the moment of inertia about center of gravity. These areas, this moment of inertia is one of the most important topics in engineering and which requires lot of attention. You should understand with respect to which axis the values of center of gravity, this moment of inertia are there, and the calculation of center of gravity is, we have discussed even Q is equal to first moment of area. Center of gravity is equal to Q by A, where A is the area of the plane. Now, let us go for some more discussions on this, because it is very much required. For example, for a rectangle, usually we have rectangle. Moment of inertia 1. We will take a rectangle with breadth B, height h, and center of gravity lies at the center. This is CG at a height of h by 2. Then I is equal to, rather I can say ICG, BH cube by 12. This is the value of ICG. Center of gravity, moment of inertia about center of gravity. Then we will go for triangle. One or two important shapes only, other shapes you can collect from your textbooks. A triangle is like this, arbitrary triangle. This is axis of CG, and here I can say axis of CG, and about center of gravity, this is height, let us say triangle, and this is breadth, base of the triangle. Then what is the value of ICG? ICG is equal to BH cube by 36. BH cube by 36. Then for a circle, of diameter D, this is the center of gravity also, and diameter is D. This is the diameter of this circle. Then ICG is equal to pi D to the power of 4 by 64. Then what is the area here? A is equal to B into H. Here area is half BH, and here area is equal to pi d square by 4. Similarly, you can go for semicircle, then you can go for a trapezium, parabola, ellipse, and in structural analysis or in the hydraulics log gates, we usually counter quadrant, rectangle gates, so that circular shapes, rectangles and triangles are more used. But however, we cannot deny the possibility of using semicircle, trapezium and parabola also. I will give for another one. Fourth, I will go for semicircle. This is also important. circle we have taken, semicircle is like this. And CG is this way. CG is, let us say, y bar, and this radius of the circle is r. That implies area is equal to pi r square by 2. Pi r square is the circle area, semicircle is pi r square by 2. And y bar is equal to 4r by 3 pi. Please remember this value. That is 0.425 r. Area we have got, center of gravity, position we have got. Now ICG is equal to, it's very very important, pi by 8 minus 8 by 9 pi. This I have derived in my previous lectures. Please refer to my previous lectures. 0.11 r to the power of 4. Here r is the radius, it's not diameter. These are the equations. Now you can go for a trapezium and other values also, as I told you. Now ultimately, here what we are supposed to know? If a vertical surface is subjected to, is submerged, this is the water, this is the water, this is the water, this is the water. It is submerged in water, submerged. What happens? This I can say, I don't take it as a surface here, it is a line. It looks like a line. When you see a vertical surface from top, it looks like a line. And surface will be a cross section of, let me say, B is the breadth, D is the depth. The cross section of this. This is vertical view. This is side view. And the hydrostatic pressure on this plane is going to act in this direction. Because this is water is here. Water is here. This water poses a pressure of, let us say, not pressure, a force of F. A force F is acting on this surface. This surface has a cross section of B and D. Now, this I area, moment of inertia, these all refer to cross-sectional area on which force is acting, hydrostatic force is acting. And let us say the height of the water column this can be more or less. The height of the water column, let us say, if it is equal to or more than the depth of the submerged surface, then depth or height of the submerged surface, then we can mean it as a submerged, fully submerged. If H is less than, this condition is fully submerged. If the height is less than the surface height, then it is partially submerged. Please understand this: partially submerged and fully submerged. The approaches should be different. We are discussing in this class about the fully submerged surface. A vertical surface having a cross-sectional area, cross-section of rectangle with a cross-sectional dimensions as B as the breadth and D is the depth, and height of the water is more than the depth of the surface. Hence, it is treated as fully submerged. When H is greater than, from the bottom of the vertical surface only we are calculating H. H is greater than D, greater than or equal to D. That implies it is fully submerged. When a particular vertical surface is fully submerged, then force acts, the hydrostatic force acts on the surface cross section as shown in the diagram. Now, what is this force? What is the formula for this force? A is the area of cross section, that is equal to B into D. As we have seen previously, it is a rectangular cross section. And H is equal to height of water rho is equal to density of water, G is equal to gravitational acceleration. In this case, what is the pressure intensity acting on the vertical surface? For that, what is the pressure intensity? Pressure is equal to rho GH. But rho GH is not directly totally acting on the surface, because H is more than the surface depth. H is more than surface depth. Then we cannot directly implement this formula. Not to be written like this. When the hydrostatic pressure is not rho GH, with what calculations we have to find out the hydrostatic pressure and its force, resultant hydrostatic force acting. Let us draw the diagram now. It is very important to understand this concept, very important concept. Even though it is a vertical line, I have drawn for the benefit of all of you to make it understand clearly. This is D, this is B, breadth, and this is, let us take it as a fully submerged. Water is a little height more than the height of the vertical surface. A fully submerged vertical surface. Let this height be h, water level, and a force is acting, hydrostatic force is acting like this. On the line, actually it is seen as a line when you see from top, and this force is the resultant hydrostatic force. Because it's a vertical surface and a rectangle, it's like it is acting on the cross-sectional area of the vertical surface. This is the cross-sectional area. Rather we can say it is like this, and like this, like this, and like this. And this is the height h. This is like this, this is like this, this is like this. And this is the D, this is the breadth, and total height of the water is h, and it's the object is fully submerged. Then the center of gravity of the object is this. The center of gravity acts at a height of d by 2 from the bottom. D by 2 of the total depth of the submerged rectangle. It is a rectangle. If it is not a rectangle, it may not be d by 2. If we take as a rectangle, it is d by 2. Then it is the center of gravity. And this, instead of d by 2, we will write it as a center of gravity height as y bar from the bottom. Center of gravity height, rather here let us say, center of gravity height from the top of the water surface. From the bottom it is y bar, from the top of the water surface, the center of gravity height is, let us say, y bar dash. Then this pressure, resultant pressure acting on the surface will have causes pressure on the vertical surface, and that vertical surface will have a center of pressure the point on a submerged surface where this total resultant pressure acts. This is Cp. This Cp. This distance is, let me say, height of the center of pressure. We are aware of the center of gravity for a given cross-section area. We know the height of the water h. From that, h minus y bar is y dash bar. That we know. But the resultant force acting on the given area of cross-section due to fluid pressure. This hydrostatic pressure acts on center of pressure. Hence, we have to take pressure is equal to total pressure is equal to rho GHC. It can be HC or we can, some books may write it as H bar or rho GH bar. Now, what is the pressure? Force. Force is equal to rho GHC into area or rho GH bar into area of cross section. This is very, very important equation. The force is acting on a submerged vertical surface and it has center of pressure as the point of action. Total resultant pressure is acting on the point center of pressure. That is the point from which point the height of the water should be calculated, the height of the water column. It should not be from the bottom, it should not be from the center of gravity, it should be from center of pressure. It should be from pressure center. For example, a question can be objective question, it is given in SSC JE or in GATE also. The total, not maybe same connected to this, the total hydrostatic pressure acts at the following point. We can say the total resultant A. Net, it can be also treated as net pressure acting on this point due to the force. A can be center of gravity, B center of pressure, C top of the surface, D bottom of the surface, vertical surface. This is in case of vertical surfaces. Vertical surfaces. The answer is clearly center of pressure. The resultant pressure acts on the center of pressure due to the hydrostatic force F acting on the vertical surface. The action of the total pressure is through the center of pressure. Another question, I will take another question also, objective type question I will explain. Now you see, from whatever you have seen in the diagram, HC is greater than Y dash bar, that means position of the center of gravity in the submerged vertical surface when it is fully submerged from the top of the water level. HC is greater than Y dash bar. You just see HC is greater than Y dash bar. That question is directly asked in staff selection or GATE. That question is the value or position or height of center of pressure in a fully submerged vertical surface is A. HC is less than center of gravity height. B. Center of gravity height below the water surface. HC center of pressure is greater than Y dash bar. C. Center of pressure is equal to Y dash bar. We can even write here like this. D. No relation. In this, answer is HC is always greater than the center of gravity, height of the center of gravity from the top of the HC is equal to center of pressure from top of water surface, height of center of height or depth. Y dash bar is equal to height or depth of center of gravity from top of water surface. Which value is higher? HC is greater than Y dash. This concept you have to understand. Wherever a fully submerged vertical object is fully submerged in a fluid, the action of the total resultant pressure will be at the center of pressure, and center of pressure is always below the center of gravity. Center of pressure is always below the center of gravity when the depth is calculated from the top water surface. Center of pressure is always below the center of gravity of for a vertically fully submerged body or surface if water level is more than the depth of the body. Height of water level. That means these are all languages from my side. Don't take it as definitions of textbook. It is always important to understand the concept rather than textbook definitions while writing the competitive examinations like SSC JE and GATE. This is the water level. This is the water level, and the surface is like this. This is like this. and force is acting on this like this, and this is B, this height is D. Please remember this diagram whenever you answer any center of pressure problem, and this water level is more than the height of the object. This is H, and this is center of gravity, from the bottom y bar, and this is from the top of the surface, it is y bar dash, and this point, let us say center of pressure, and this center of pressure is this. Please remember, along with me you might have drawn this diagram. Please draw, whenever I draw the diagram, please draw along with me, either H bar or HC. Then what is the quantum of it? Now we have to know what is the value, how to calculate the value. We got that some center of pressure is there, on this total force is acting, hydrostatic force, and that point is the crucial point, and through from that point only we can find out the hydrostatic pressure acting. Now, from the given cross section, I is calculated, ICG is equal to DD cube by 12 for rectangle. For other shapes I have already discussed. Once ICG is known and area is equal to, I am only giving as an example, area is equal to BD, then the center of pressure or H bar is equal to y bar dash plus I by ICG by A into y bar dash. This is the formula. From the formula also you can say that from center of gravity, this is the depth of center of gravity from top water surface. All values are calculated from the top water surface, and I is the moment of inertia. A is the area of cross section. Area is positive, I is positive, y dash bar is positive, hence H bar is equal to HC is equal to center of pressure is equal to height of center of pressure is equal to, or depth of center of pressure we can say from the top is equal to y dash bar plus some value. That implies H bar or HC is greater than y dash bar. This is very important observation. This is what is asked. The quantum of the difference is ICG by AY bar. ICG by AY bar dash. With this is the concept of the center of pressure, and if any value addition is there because of this video and my lecture, please view, review, comment on my videos, share and subscribe. I will give the link, playlist link for all the other videos from my channel in the description. Best of luck to everybody. My channel is CIVIL-MECH-MATHS-CONCEPTS. Once again, best of luck to everybody. Thank you for viewing my lecture. Thank you for listening to me.